So it's fascinating. So the Moore's law kind of a notion applies for the bad guys as well.
Absolutely.
They're getting equipped with new technology. They're getting more sophisticated, and the cost of attack is getting less and less. That brings me to a very interesting point. When we build a vehicle, when we build a system for a vehicle, as a tier 2 company, we build the software for the vehicle. We think about a lifespan of 20 years. I mean, that's a really, really, really long lifespan when it comes to anything today.
Exactly.
Yeah? And in terms of cybersecurity, it is way too long. So the idea is we're trying to develop this over-the-air update of the software and that kind of thing. The problem is that is creating new ways to attack for the attackers.
That's another attack vector.
That's another attack vector. So at the same time, we have to also look at the cost of the vehicle. How do you think pragmatically the industry should deal with the challenge?
Well, I mean, we've seen this already with mainstream operating systems. So it's exactly the same story. Back in the days, or we still probably have some mainstream operating system that says, well, hey, we are invincible, like nobody can touch us. That has been proven wrong, by the way, but I guess somebody still have that kind of opinion somewhere. But I mean, made by man software, there will always be vulnerabilities. It's not question if, it's question when somebody finds out about them, right? So it takes a lot of resources and cost to build really good software with few or almost no known vulnerabilities or possible vulnerabilities. I don't believe that you can build anything without those kind of vulnerabilities, but it's just a matter of, how much knowledge we have or how much persistency we have to figure out that there is a vulnerability actually in the system. And then as we observe mainstream operating system, we see huge investments being made. Like take an operating system like Windows and look at the journey they've made, starting with the Windows NT and then up till now with the Windows 10 and Windows Server 2019. That's a whole totally different story if you look at the investment in security in these two versions. Today, we are relying on hardware-based security. There are a lot of measures taken care of by the hardware. Hardware is there assisting and observing what's going on. We start talking about validation methods where the hardware will look at whatever is executing in software and, hey, that looks valid, that doesn't look valid anymore. We know it shouldn't behave this way. Behavioral analysis are getting more and more into our systems. And the hardware itself will start doing or has started doing some of these behavioral analysis on those systems. This is an improper execution path. That application shouldn't behave that way, for instance. So I think we need, if we cannot cope with, like, if we think that time is a problem and the type of investments I need to update the software, it's probably impossible because that something is offline for too long time. We need to start looking at more of a whitelisting model and say, hey, there is an execution path. If you deviate from that, we choose to terminate whatever that process is. And then that will obviously get in conflict with, okay, if that was a self-driving capability, then what happens? So we need to be able to flip back to manual mode and say, hey, tell the driver, okay, you're
in charge.
We cannot assist you anymore. You have to drive the thing yourself, right? So we need to put these kind of measures in place. Even though we have the ability we have a channel where we can push updates, there will be things coming across that and making possibly some devices impossible to update for some time. What kind of consideration should we have about that? Is it just fine? I mean, just look at the WannaCry. I just go back there and see, because that's a brilliant example of, there was a patch, but we had a lot of very critical systems out there that weren't patched because of different circumstances. Some of them were isolated, so they couldn't actually reach out to the patching channel. So, and when somebody stepped into that isolated system, then they made a havoc. So how is that comparable with this type of industry?